Ladies and gentlemen, good morning and a very warm welcome to today's STOA meeting, presenting the results of two major STOA studies, namely health impact of 5G and environmental impact of 5G. Today also we have the European Science Media Hub knowledge map on 5G to be presented, and you will see it's fascinating and really informative. So the hashtag today is STOA 5G, and our Twitter handle is EP science tech, and I encourage you to share this widely on social media because it's a very, very interesting topic that has raised a lot of debate and discussions. Today, we also inaugurate a new format of events. It's called STOA Meets Experts, more focused, delivering high visibility interaction between members and experts. As chair of STOA, the panel for the future of science and technology, I'm very proud for our evidence-based policy making to provide independent research on scientific and technological topics. It is absolutely crucial in the areas, especially of healthcare and environmental sustainability, that our policy making will be guided by a scientific evidence. So therefore, we welcome the contributions of our eminent speakers today to this event, as the introduction of 5G across the EU is expected to bring new opportunities for citizens and businesses through faster browsing, streaming, and downloading, as well as better connectivity, almost uninterrupted. So it would be a new stage in the evolution of our increasingly interconnected world. 5G wireless communication offers also numerous advantages, for instance, to medical research. Let's consider also under the light of the pandemic how much faster we would be able to process data, and high gigabit connectivity would facilitate that. So 5G would be a foundation technology for the Internet of Things, where machines can also communicate with each other, even in an autonomous way. However, 5G also brings new threats to human and animal health and also to the environment. If we want all urban areas to access uninterrupted fifth generation wireless communication and to have the coverage to do so, by the installation of 5G antenna masts situated closely together and operating alongside the existing 2 to 4G masts, the number of high frequency powered base stations and all the other needed devices will increase a lot. So the question is if researchers should answer whether such high frequencies, 6 to 100 gigahertz millimeter waves, in combination with our existing radio frequency waves, could have a negative impact on human health and the environment. The scientific community at this point seems to be divided. Some consider that more research is needed on potential negative biological effects of electromagnetic fields and 5G, notably on the incidence of some human diseases as a result of exposure to such fields. Even cancer and leukemia has been mentioned, and in this light, the Council recommendation has determined basic restrictions for limiting exposure to electromagnetic fields by establishing maximum values that should not be exceeded. This also means that we need more and further studies. We have evidence from recent studies in experimental animals, as well as from epidemiological studies, that lower athermal levels of radio frequency may increase the risk of cancer and other health outcomes, including possible cognitive and behavioral effects. While the evidence to date is not conclusive, we have evidence towards that direction. And if these findings are confirmed, then exposure limits based on short tissue heating effects would in fact not be sufficiently protective and wouldn't follow, of course, the precautionary principle that EU is respecting. The use of 5G is still in its infancy, though. Mobile phone operators offer the 5G contracts, but the technology is far from being fully operational. The use of much higher frequencies is foreseen for the future. So currently, the population exposure is still very limited, and it's therefore still possible to call for further evaluation of the impact of 5G, and what it would mean if it's fully deployed on health using epidemiological methods. Exposure measurements is also very difficult because technological advances such as massive multiple input and multiple output and beamforming dramatically affect the spatial and temporal distribution of exposure and standard measurement protocols, they cannot currently take this into account. So research is needed, therefore, on measurement protocols, exposure assessment, epidemiology, as well as in vitro and in vivo experimental studies to evaluate the impact on health of new exposure characteristics, including frequency band linked to the deployment of 5G. So we could have safe deployment of 5G, but we are not ready to base it on scientific data. In order to debate these issues, the STOA panel has organized last December a virtual workshop, and today the results of the two studies on health and environmental impacts are presented. The Science Media Hub knowledge map will be presented, as I mentioned, and it's developed through a software that combines visual and concept maps with multiple layers, and very, very useful and informative. That I think it would be very interesting and undoubtedly enlightening. Like the talks that we will listen to now, and I'm very pleased to have with me two exceptional colleagues that were also part of our team that we initiated these studies, and we also called for the Commission to increase their studies and the speed, and also the scientific advisory mechanism. Michelle Rivasi from the Greens and Ivo Christoph from the Social Democrats, STOA panel members both and very active. Without further ado, I would like to give the floor to them for their remarks, and my colleagues will also provide the conclusions of this meeting, and so we will listen to what they think and their assessment of these studies. So we start, of course, with Michelle. Michelle, the floor is yours.
Merci, Madame la Présidente.
Thank you, Chairwoman, for introducing me. First of all, I would like to talk about STOA and say thank you to them. STOA, the whole team, all the colleagues who are part of it, because there was a bit of a lack of something from the Commission when in 2013 they decided to form a 5G public-private partnership, which was a huge project, a 700 million euro project to research 5G, but there was no impact study, no health impact study, and no environmental impact study. Now, it's the European Parliament who has to step in. We, as the STOA, asked for two studies, one for the environment, for invertebrates, vertebrates, plant life, the impact of these frequencies on those areas, and on health. And that was with the Ramazzini Institute. And this shows that the European Parliament, as opposed to the lack of action from the Commission, was able to commission these studies. Secondly, I'd like to talk about what these studies have done. So, with the study on health talks about the fact that there are effects, and they talk about carcinogenic effects and reproductive effects. These are animal studies and show that 5G, especially the frequency band going from 700 megahertz to up to 6 gigahertz, have carcinogenic effects. And these effects also affect reproduction and development. There's a huge gap here. And as you said, Madam Chair, we're talking about the millimeter range around 26 gigahertz. There's no information here. We don't know what happens with these frequencies and what the effect is going to be in the future. We don't have the studies to show the environmental effects and health effects coming from that. Thirdly, what I'd like to mention is that the basis on which standards were set. There's IGNIP, the IPCC, as you know, that this IGNIP, which is an international organization that that did not take account in any way of these sorts of effects. They only talked about thermic effects, not the athermic effects. We are talking about athermic effects, and therefore you cannot base ourselves on this organization's recommendations, because they did not work with independent and objective criteria, especially when it comes to the overall effects. Another thing I would like to talk to you about when it comes to these health studies are the recommendations. If on a European level we use the precautionary principle, then the recommended levels need to be much lower than the 6 volts that have been recommended previously, whether that you're talking about in Switzerland or in Italy or even in Brussels or Paris. This is a challenge, therefore, to the recommended levels from the Commission. We need to have recommendations for individual exposure, because we have 2, 3, 4, now 5G. 5G is something that we have now, even if it's not developed all over Europe, and there's high levels of exposure. And we need to focus on all these areas where there are not adequate studies on the impacts and on these millimeter ranges. And looking at the presentations in terms of health and 5G, once again, I'd just like to say thank you for those, and thank you to the Parliament who stepped in and stepped up to fill the gap left behind by the Commission. We have this at the level of operators, and just the minimum of the minimum is to just do these health impact studies, because we have to ask this question of whether 5G can have health effects. And the studies show that there are impacts, and that we need to be extremely vigilant when it comes to developing this technology. Thank you very much.
Dear Ms. Kali, Professor Israel, Madame Ivasi, dear experts, it's an honor for me to host today's meeting as well in my capacity as an co-initiator for these 2 studies. I am interested and look forward to find out the results of these 2 studies, and they were carried out under the guidance of STOA, so this gives them the mark of quality unbiased expert science. It's clear that the neutrality of existing studies is often questioned due to the scale of the economic interests and the strong positioning of the industry. More and more often, we see the reprehensible practice for corporations financing studies in order to validate technologies leading a lot of economic benefit, but dubious effects in terms of human health and environment. This widely spread practice often misleads the public opinion in the direction that it serves the companies. I think the public interest and the care for diversity and human health should be leading in our economic deliberations. We should have an objective, unbiased scientific evaluation which would help us our discretion of truths through and half-truths. I think the presentation of these 2 studies will introduce some common sense in this area. I use this opportunity to share my gratitude for Ms. Fiorella Belpoggi from the Ramazzini Institute in Bologna and Mr. Arno Tillens in the Ghent University of Belgium, who led these 2 studies. Although some additional challenges were presented due to the pandemic with the finalization of these studies, today we have a set of specific recommendations, and I look forward to hearing them. And now I would like to give the floor to Mr. Michel Israel in Sofia.
Thank you very much, Mr. Christoph. Dear members of the European Parliament and of the STOA Science Technology Network, dear colleagues, dear attendants, it's an honor for me to be a moderator of this important meeting. I'm sorry that my English is not so fluent. First of all, I would like to introduce myself. My name is Michel Israel. I have education degrees in physics, biophysics, medical physics, and really I'm working as a professor, health physicist, both for the Medical University Pleven and the National Center of Public Health and Analysis, Sofia. My scope of interest includes non-ionizing radiation, measurements, exposure risk assessment, research, risk communication, developing methods, standards, teaching, training in the field of occupational environmental health, connected with exposure to electromagnetic fields and other physical factors on human body. I am a member of the International Advisory Committee of WHO International Projects Inter-Sun and Electromagnetic Fields, of the American Conference of Governmental Industrial Hygienists, and expert at the European Commission developing the EU Directive 35 for exposure of electromagnetic fields to workers and others. Several words about the National Center of Public Health and Analysis. It is a structure of the national healthcare system and carries out activities on public health protection, health promotion, and disease prevention, information security management of healthcare. One of the main activities in this area is to examine the population health status and its relation to environmental factors and living conditions, to perform exposure and health risk assessment from the effects of biological, chemical, physical hazards in the environment and in the workplace, including non-ionizing radiation. Now, I briefly will explain the structure of the meeting. There will be three presentations of Fiorella Belpoggi, Arno Tielemans, Julia Koberlein, and Bernard Schultz. After this, there will be a discussion among the authors of the two studies here. Three scientists invited as discussants later: Joachim Schutz, Kurt Streif, and Martin Watsche, with members of the European Parliament. Please respect the time for your presentation. And another advice to the speakers to speak slowly in order to allow the interpreters an adequate translation. There is interpretation in English, French, Spanish, Bulgarian, Italian. Now I give the floor to Fiorella Belpoggi. She is the scientific director of the Ramazzini Institute, Bologna, Italy. Her research interests include short and long-term toxicity studies on chemical and physical agents. Dr. Belpoggi has authored more than 150 publications published in peer-reviewed journals. You have the floor, Fiorella, please.
Buongiorno a tutti.
Good morning to everybody, and thank you very, very much indeed for giving me the opportunity to discuss this problem with you and to report back to you on a study which we have been conducting. But I particularly would like to thank you for your invitation to participate in such an eminent platform discussion. I think it will be very instructive for me to hear from experts and from parliamentarians as to how they would advise we deal with this problem. So thank you very much. Next slide, please. So this is a little background. When we talk of 5G, we are not, as you know, talking about a new technology, but rather of an evolution of technology which exists already, which has developed from 1G to 4G, with which we're more familiar. So how is it distinguished in nature? 5G networks will work with several different frequencies from less than 1 gigahertz to 3.6 gigahertz or 25 gigahertz. As Ms. Rivasi has said, some of these frequencies have been or are currently being used for earlier mobile communication generations and were studied for their health impact. Much higher radio frequencies are, however, planned for use at 5G evolution, 100 and more micrometers, and they have different characteristics. So these frequencies, the lower frequencies, less than 1 gigahertz and 3.6 gigahertz, have the same characteristics as the wavelengths that we're already familiar with and which we currently use. In terms of their impact on health, we have some studies available now. The best evidence that we have from all being published and reviewed on health is informative, but it's based on this range of wavelengths. In terms of the higher frequencies, as colleagues have said, more research is necessary and will indeed be done in the future. It's been very difficult for us to study it adequately up till now because it wasn't widely used, so we weren't able to get representative information. We didn't have enough individuals covered by the requisite wavelengths, and we didn't have any studies on animals and animal health either. We concentrated on the non-thermal effects. ICNIRP drafted guidelines in 1998, which were updated most recently in 2020. And these guidelines give a detailed and exhaustive analysis of all possible effects related to heating of animal tissue and human tissue. But the biological effects of a non-thermal nature have not been studied in the same detail for a number of reasons. First of all, the non-thermal effects are known to exist for sure. We are absolutely certain about this because electromagnetic fields operating at some of the frequencies which are used for mobile telephony are applied also in medicine for therapeutic purposes. And they're used precisely because we know that they have a positive interaction with the animal or human tissue which is to be treated. So we have been structuring our study in a particular way. This is the methodology here. The studies have been divided into two groups. We've had to look at a large number of studies which have been done. We've tried to select the most informative parameters. We've divided the studies into two groups in the first instance, one on the lowest frequencies and one on the higher frequencies. And so for the first one, as I was saying, we have found that there is a certain amount of evidence for the bandwidth from 24 to 100 gigahertz, the higher frequencies. We have not got sufficient information. And we had to structure our studies in this way because of the different characteristics of the various frequencies and the different impact. Next slide, please. So now on the criteria for evaluation. This is the basis on which we've structured our work for scientific reasons, because we wanted to be absolutely objective and scientific on this and use well-established familiar criteria. So we based our criteria on the IARC preamble and the criteria there, which have actually been in use for some 40 years now and are based on particular chemical and physical observations. So we look at evidence in humans, epidemiological studies, evidence in animals, which has been carried out to some extent. And then we integrate these evaluations to get an overall evaluation, as we call it, of the impact. We therefore have to evaluate each series of studies independently, and then we have to correlate it with other studies, so that we then have 3 separate evaluations as a base, which are then integrated to give us the overall final classification, whereby we're able to look at the scientific impact and potential adverse effects deriving from exposure. Next slide. So, when we began to cross-reference the data and look at all the information that we have gleaned from thousands of publications on which our research has been based, when we began to narrow it down to the studies which were appropriate for experimental use, we reached a number of conclusions, as IARC had done, evaluating all the work available up to from 2011 to 2020 and updating the results that they had done, so that we now have a range of evidence up to 2020. We reached some conclusions. They may be limited to some extent and have some reservations, but we have observed that glioma, a tumour of the brain, and acoustic neuroma may be caused by exposure to radiofrequency radiation from wireless phones. The human evidence is still limited, and I should add that no adequate studies have been performed on the effects of the higher frequencies. Next slide. We have carried out experiments on animals, and we have looked at carcinogenicity, and we have, to do this, updated the evidence which had been compiled by IARC up to 2011, which gave some clear results. At that point, there were not a large number of studies, but the studies which were carried out were considered to be perfectly valid, but requiring further analysis. So now we have the National Toxicology Programme study, which is more recent, having been published in 2018, and we also have a review of that done by a number of experts who have published their analysis and final report on this. And the conclusions that they have reached is that there is clear evidence of carcinogenicity, and that there is an evidence of an increase in brain tumours, and there are impacts on the Schwann cells of the peripheral nervous system. So these are the same types of tumours which were observed in epidemiological studies too on human beings. Therefore, the more recent studies do indeed seem to confirm what was identified in earlier epidemiological studies, both DP studies in America and subsequent studies which have been done by the Institute in Bologna more recently. As far as the higher frequencies are concerned, again, we feel that we do not yet have adequate studies results on athermal effects as yet. Next slide. So now reproduction and development effects in human. Because, as I said, we have identified cancer as an endpoint, and we have looked further at adverse impacts on development, because these are two objective observations which have been confirmed by studies. If you look at pathologists' studies globally, you will see that there has been diagnosis of quite a number of types of tumour which are not obviously medically diagnosed. They're not self-reported, and there is laboratory evidence to back this up. The same is true on fertility. Sperm counts remain the same in all the laboratories which have been carrying out these studies. As far as the epidemiological studies have shown, there is limited evidence of adverse effects on the fertility of men. And the studies which have borne this out have been validated by a number of experts. The point being that it would appear that it is the ability of the sperm to reach its destination, to swim far enough and strongly enough to reach its destination, which is compromised. There have also been a number of different studies, developmental studies, that is to say, on neurological and cognitive development of children. Children who were born to mothers who used mobile phones a lot during pregnancy. Now, again, this is a review which has focused on lower bandwidths because there were no studies, again, on the higher frequencies. Next slide, please. Thank you. So, the results. These are based on experiments on animals. There have been control groups in a controlled environment, and the effect on fertility in the male rat and the male mouse have been clearly established. So there is sufficient evidence of adverse effects on fertility in a male rat and in the male mouse. There is more limited evidence of adverse effects on female mouse fertility. Not rats as yet, but in mice. And there is limited evidence of adverse effects on the development in the offspring of both rats and mice, which were exposed during the period of gestation, whilst embryos in utero. Once again, for the higher frequency bandwidths, we don't have adequate studies for further research conclusions at the moment. So the final conclusions there are these. We have integrated the studies from the epidemiological studies, the evaluation of the experimental studies, and we've integrated all the data and reached the following conclusions. So the current frequencies, which are higher than the lower ones, which were at the moment, these conclusions are based on best evidence, I should say. Probably these frequencies 450 to 6,000 are probably carcinogenic to humans. 24 to 100, again, we don't have adequate studies as a basis to evaluate fully the potential adverse impact, but it would appear that both for man and possibly for women, there can be an adverse impact on the development of embryos, fetuses and newborns. So the concern is that in the male there is a correlation between exposure and the effect on the quality of the sperm, and the concern for women is the impact on the development of embryos, fetuses and newborns when the mother has used a mobile phone extensively during pregnancy. Once again, and the higher frequencies, we don't have any adequate studies on the thermal, non-thermal effects. So now, next slide, on to the policy options. Opting for novel technology for mobile phones that enables RF and EMF exposures to be reduced. 61 voltmeter is the basis for our further consideration, looking at the thermal and non-thermal impact. We know that as far as men are concerned, the intense use of the mobile phone does have an impact, and therefore one of the first things which should be done, and perhaps the easiest thing to do, would be to ask mobile phone companies to produce phones which have less of an impact, which emit less energy and therefore expose the body less. This could be done in a quite straightforward fashion. For example, the phone would only be able to emit radiation when it was a certain distance from the body, and also to limit the levels of radiation. Our studies are based on thermal levels, and we've looked in detail in our studies at a number of different radiation levels, and the lowest dose which has an impact on Schwann tissue is 50 voltmeter, which could be actually considered the lower level. In the way that we do for chemicals, this is the lowest level where we have identified adverse impacts and emissions. So we need to look at exposure, and we need to look at what recommendations we could be making. We can't be using 5G exclusively through cable, but we do need to look at what sort of connectivity we provide in public places, in schools, in libraries, for example, and in the public space in general. And as Michelle Rivasi has very rightly flagged up already when she spoke earlier, we need a lot more scientific research of a multidisciplinary nature. We just don't have enough as yet. So we need to have more studies by physicists and in industry and by independent scientists. And what we need to do is have all these studies run in parallel and in conjunction, so that we can then extrapolate from all these different sources the appropriate conclusions, so that we can really make progress on understanding what the potential health impacts are of 5G, which is, after all, going to be all pervasive right around the globe. We've already got mobile phone networks very widely disseminated throughout the globe. I've looked at a lot of biographical information, doing literature reviews, and I've seen that there is a certain amount of monitoring going on as to the impact of these mobile phone networks. I'm extremely concerned about this, and I'm extremely motivated by this research, and I think the citizens don't have any kind of idea what is up ahead of us. It's not just the frequencies which have an impact, it's also the magnetic fields that are generated which have an impact, and therefore they should be limited. So rather than having new frequencies, newer frequencies which will have greater efficiency, we need to be looking at the health aspect and limiting it so that we can protect the health of our citizens. I'd like to thank you very much indeed for your attention, and thank you again for this wonderful opportunity. Thank you.
Mr. Israel, you can press the speak button, please.
Okay, thank you. Thank you very much. Thank you, Professor Belpoggi, for the interesting presentation. Now I give the floor to Professor Arno Tierlens, who is Associate Professor in the WAVES Research Group of Ghent University and IMEC, Ghent, Belgium. He is a postdoctoral fellow in fundamental research of the Research Foundation Flanders, Belgium. Please, you have the floor, Professor Tierlens.
Thank you, Mr. Israel, and good morning, everyone. I will be presenting the results of my study on the effects on wildlife, meaning flora and fauna, of fifth generation wireless communication, and which entailed a literature review of effects of radio frequency electromagnetic field exposure on non-human vertebrates, invertebrates, and plants. So next slide, please. Yeah, so when we're talking about exposure to radio frequency electromagnetic fields, these fields are usually emitted by a radio frequency source, which is commonly an antenna, as I've shown here on the left. And this antenna will emit radio frequency electromagnetic fields that will travel as waves in space. So next slide, please. So these waves, they are characterized by two main parameters. Yeah, if you can put up the next slide. So the first parameter is the amplitude of those waves. So this is like the level of the exposure or the intensity of the exposure. And then on the next slide, the second parameter that's important is the frequency or the wavelength of these waves. So next slide, please. And yeah, so that's illustrated over here. Next slide again. And so these antennas can be found nearly everywhere in the European Union, and so the fields that are emitted by these antennas are also like nearly everywhere, and humans and organisms, they are exposed to these fields. So I've shown an example here of an organism that can be found in the environment, and these fields will be incident onto the body of these organisms. Next slide. And so part of these fields, it will be reflected of those organisms, but part of these fields will also penetrate, can penetrate those organisms. And so these internal fields can be partially absorbed in these organisms, and so these internal fields and this absorption can have biological effects. And this absorption and the quantity of internal fields within those organisms and also those effects depend on those two parameters that I discussed earlier, the frequency on the one hand and the amplitude or the level of the exposure on the other hand. So next slide. Now, when we're talking about radio frequency electromagnetic field exposure in telecommunication networks in specific, there are two main sources of this exposure. On the one hand, that is shown here on the left, you have like the user equipment or the personal devices that humans use, and they emit these radio frequency electromagnetic fields. And this is one source of exposure. And the other main source of exposure are the base station antennas, shown here on the right. They're typically mounted on a tower or on very high buildings, and they also emit these radio frequency electromagnetic fields. So next slide. And so the most important thing here is of course that nearly all non-human organisms are not users of this telecommunication network. And so for them, the dominant source of exposure of radio frequency electromagnetic fields are these base station antennas. And so I will be focusing on those antennas further in this talk. So next slide, please. And so it is the expectations that in the near future there will be an update of the telecommunication networks. And these telecommunication networks, they're updated in what is called the generations of telecommunication networks, and we're now at the fifth generation, also called 5G. And so one of the major changes in the new networks is that they will be operating at a new set of carrier frequencies. Current telecommunication networks operate mainly between 450 megahertz and 6 gigahertz. But in 5G networks, there will be 3 new frequency bands that are added to the spectrum. So 2 bands, one around 700 megahertz and one around 3.5 gigahertz will be added to that already used spectrum. And then there will be a new frequency band at higher carrier frequencies around 26 gigahertz. And so alongside these changes in carrier frequencies, there are also other technological changes in the network. And all of these factors combined will change the radio frequency electromagnetic field exposure of wildlife in the environment. And because there's like a change that is expected in this exposure, we executed a literature review on potential biological effects of exposure to these radio frequency electromagnetic fields, taking into account these anticipated changes in the network. So next slide, please. So on this slide I have summarized like the most important aspects of the methodology that I used. So I started from a literature search in ISI Web of Science. This is a database of peer-reviewed scientific journal publications. And this resulted in a whole set of scientific publications which were subdivided in 6 categories. First, they were split based on the exposed population, which was wildlife, split in 3 different categories: invertebrates, non-human vertebrates, and plants and fungi. And then these 3 categories were further subdivided based on the frequency of exposure. So I split them in 2 different categories. There's a lower frequency band from 450 megahertz up to 6 gigahertz, which corresponds to the current telecommunication networks. And then there's a higher frequency band going from 6 gigahertz to 300 gigahertz. These are the frequencies that would correspond to the future telecommunication networks, let's say. And so in each of these 6 categories, I executed a systematic literature review, and the results will be presented on the next slide. So next slide. Yeah, so what I've shown here on this slide, on the vertical axis, you can see the number of peer-reviewed publications that were found in the database search. And these are split for all 6 categories. And so on the left, you have all the papers that were found studying exposures below 6 gigahertz. On the right, the papers studying the exposures above 6 gigahertz. And then they are split according to type of organism. And so there are 2 important things that are shown on this slide. So first, if you compare the number of papers that are found below 6 gigahertz or that exist below 6 gigahertz, and the number of papers that were found in the database search above 6 gigahertz, you see that there are many more papers that have investigated radio frequency exposure below 6 gigahertz. So the number of papers above 6 gigahertz is really limited. So there is like a decent amount of papers, like let's say 160 papers on non-human vertebrates. But on invertebrates and fungi and plants, there's not a lot of research out there. We're talking about less than 50 scientific publications that can be found. And so this is really, really like limited, especially if you compare it to research on non-human vertebrates, where you can find hundreds and maybe thousands of papers that investigate this. A second important aspect is that even if we look at those papers that have been executed below 6 gigahertz, there's still a very large discrepancy between the amount of research that's been done on vertebrates versus the amount of research that's done on other organisms. So there's just in total not a lot of research out there that focuses on invertebrates, plants, or fungi. So next slide, please. So what I've shown here in a lighter color are the amount of studies that were then retained in the review. So the lighter part of the bars indicate how many studies out of the ones that were found were included in the review study. And what's important here is that if you look at that blue bar on the right, that there's a relatively high amount of scientific publications on vertebrates that were retained, so those passed the predefined quality criteria. But if you look at invertebrates, fungi, and plants, the relative amount of papers that were retained in the review are lower than the ones for vertebrates. And this indicates that the quality of research in these areas is actually lower. And that's also a problem, of course, because what you would like to have is very high quality publications in all studied categories, of course. And so the next slide. So in the conclusion out of this general review, I would say that more research is needed, in particular at frequencies above 6 gigahertz, and then especially on plants, fungi, and invertebrates. And of course, because there is such a limited amount of evidence available, there is uncertainty on potential biological effects of radio frequency electromagnetic field exposure, especially in those categories that I mentioned beforehand. Next slide, please. So a second important result of this review that I would like to highlight is that the review did show that dielectric heating due to radiofrequency electromagnetic field exposure is shown for all the studied organisms and at all the studied frequencies. And this heating is of course associated with a variety of biological effects in all these organisms. And this also means that there's always a threshold for any organism at any radio frequency when this heating will occur. And what the review also showed is that these levels, these thermal levels, let's say, are frequency and species dependent. And this implies that if you want to do protective policy making regarding radio frequency electromagnetic field exposure, when you want to set exposure limits, let's say, and you do that when focusing on one species, for example humans, which are now at the focus of the current guidelines and the current exposure limits, that it will not guarantee protection for all the other species. You need a more broader exposure limit in order to guarantee that. Next slide, please. And of course there are also other radio frequency electromagnetic field exposure effects that are studied in literature. And I've summarized those in the report. And so based on these results, I formulated 4 policy options that I will present in the following slides. So next slide, please. Yeah. So a first policy option would be to fund more research on environmental exposure to radio frequency electromagnetic fields. Why is this important? Well, the current protective policy making regarding this exposure only considers biological effects related to human health and disregards any biological effects that are not related to human health. But if one would be interested in doing protective policy making for plants, fungi or non-human animals, then this should be based on scientific literature that targets these species. However, as I have shown, the research on radiofrequency electromagnetic field exposure on non-vertebrates and non-human animals is rather limited. So in order to mitigate this, it would be an option to fund research on plants, fungi and invertebrates at frequencies below 6 GHz and all non-human organisms at frequencies above 6 GHz. Next slide, please. So a second policy option would be to execute systematic measurements and monitoring of environmental radio frequency electromagnetic field exposure. Why would you do this? Well, as I said, there's now an uncertainty on potential effects of radio frequency electromagnetic field exposure of wildlife just because there's not that much research out there, right? And so it might be prudent to monitor environmental radio frequency electromagnetic field exposure so that then in a later stage and when there is more evidence available we can retroactively assess what type of potential effects might have occurred in the current exposure, right? And so 2 questions definitely need answering, and this is like, what is the radio frequency electromagnetic field exposure of wildlife and how will this exposure change in future networks? And I've shown some illustrations here of such measurements that my research group has done near beehives, just to show you that methods to perform such measurements exist, that they are well established. There are many companies in the EU that can do these measurements. This is not a scientific or exploratory endeavor. This is just a task that can be done using existing methods. Next slide, please. So a third policy option focuses on monitoring of base station antennas. So as I've said, the dominant source of this exposure for wildlife are base station antennas. So I've shown an example here on the left. They're typically mounted on towers or high buildings, and then they cover a whole area where they provide network connectivity. And on the right I've shown an example of how such a base station antenna looks like for 5G networks. So you can see that this is like an array of a lot of small antennas. Those are those circles, which are all controlled using those blue cables that you can see on the bottom. Next slide, please. And so it are the network operators that can control the input parameters on each of these antenna elements. And it are exactly these parameters that will determine what environmental exposure to radio frequency electromagnetic fields is. And so there's a one-on-one relationship between these parameters and exposure. And if these parameters are known, the exposure, the environmental exposure is also known. However, it is now the case that these input parameters are proprietary information that is currently only known to the network operators. These are not disclosed publicly, or they are not disclosed to any governmental agency. And so if you would be interested in monitoring environmental exposure, then it would be an idea to ask them to disclose this information. And this is particularly important in 5G networks, where there is the expectation that these input parameters will become dynamic. So in the current networks, these are rather static. But in 5G networks, these will vary over time, they will change over time, and the only one that will know how they change over time and how the exposure changes over time will be the network operators. And so it might be an idea to ask them to disclose this information. Next slide, please. And so finally, a final policy option that I suggest is to look at exposure near the base station antennas. So it is known from literature that for all organisms, the radio frequency electromagnetic field exposure is the highest near the antennas. So I've shown an example here for a honeybee near an antenna. So on the vertical axis of this graph on the left, you can see the absorption in a honeybee, and on the horizontal axis, the separation distance between a honeybee and an antenna. And what you can see is that this exposure is highest near the antenna, right? And this is true for all organisms. Next slide, please. And so it is also true for humans. And for humans, precautionary measures are taken to avoid these high exposures near base station antennas. And these are done in the form of compliance studies. So whenever a network operator installs a new base station antenna, he or she has to do a study where they determine what the exposure will be in the environment, and then based on that exposure, they will limit the emitted power by these antennas in order to limit human exposure. And in parallel, there are also measures put into place that ensure minimal separation between these base station antennas and humans. So for example, they will put fences up around these towers or around antennas, or they will make sure that no one can climb a tower and get really close to a base station antenna. Next slide, please. Yeah, so it is an option for policymakers to also require similar studies that also take into account non-human organisms, because right now these studies are only done taking into account humans. And so this assessment could then make use of exposure limits that not only take into account human health effects, but also all potential biological effects of radio frequency electromagnetic field exposure. This assessment could be based on measurements and simulations that take into account differences between different organisms that might appear in front of such an antenna. We can think about flying organisms or climbing organisms. And obviously it's also possible to do interventions that ensure a minimal separation between organisms and these base station antennas. So next slide, please. Yeah, next slide. As what I've shown here are some examples of very innovative ways of mounting base station antennas that are already being used in the field. The goal of these interventions is to avoid like visual pollution. But one might think of very similar interventions near these base station antennas that can ensure that there is a minimal separation between these antennas and any organism that might appear in front of such an antenna. Okay, next slide, please. So in conclusion, wildlife is exposed to radio frequency electromagnetic fields, mainly emitted by telecommunication networks, and this exposure is expected to change in the future, and that's why we executed this literature review on biological effects of radio frequency electromagnetic field exposure, and based on the results of this review, I formulated several policy options. I would like to thank you for your attention and thank the STOA for their trust in me in executing this study. And if you have any questions after this session, feel free to contact me on my email address. You can find it at the bottom of my slides. Thank you so much.
Thank you, Professor Tillens. I give the floor to Julia Koberlein and Bernard Scholz for the third presenters. Julia Koberlein and Bernard Scholz are co-founder of Context Lab. In their presentation, they give an overview of how the European Science Media Hub knowledge map on 5G works and what it contains. Please, you have the floor.
Yeah, thank you very much. Operator, could you please stop the presentation for a moment so we give you a hint? Thank you very much. So, thank you very much for the introduction, and we also would like to thank you for this great opportunity to present our work on the ESMH 5G mapping during this panel. So why did we cover the topic of 5G in a map? And what does map mean in this case? A big issue like 5G in Europe obviously is not simply a technological issue about how this technology works. It also has political, economical, and social aspects, which are all interconnected on several layers and levels. So that's why a topic like 5G is very complex, and this is also why it's very difficult to convey it in its entirety in linear formats. But in order to understand the whole topic, it's fundamentally important to see exactly this larger context. This is why we at Context Lab have developed a new way to communicate knowledge in its context. With interactive knowledge maps, you can delve deeper into a topic, discover all connections, and understand all the details. To give you a brief impression of how this looks like for the 5G mapping, I just want to change my camera for a moment, just a second. So you will see my tablet shortly. So now you can see my tablet. But the map is not only working on tablets, of course, this is working also in browsers, but it was now easier to show you my tablet. As soon as you enter the URL of the map into your browser, you will enter the map. In the very first view, you will see all relevant sections of the topic. When you start zooming, as Bernard is showing here, on the iPad this is done with touch gestures, on the computer with scroll wheels, you will literally delve into the topic. The deeper you zoom, the more detailed the context appears visually. But this visualization of the connections is only one part of the mapping. If you click on one of the nodes, a panel with an article to this very aspect opens. For the 5G mapping, it was particularly important to create all content according to scientific standards. In order to make the research transparent and comprehensible, all sources are included both for each article and general for the entire map project. You will find this sources list in the table of contents of the map. In addition to these articles, the map also contains multimedia content, like, for example, videos showing interviews with experts, or as you can see here, or like here, infographics with which explain certain aspects visually. All contents of the map can be found playfully within the map via exploring, zooming, and panning, as Bernard is showing here. But you also have the opportunity to directly search and look for content via the table of contents or via the integrated search in the map. So this was a very brief introduction to how the map works. I will switch my camera back now. And with this, with that, I want like to pass on to Bernhard, who will tell you more about the content which you will find in the map.
Thank you very much, Julia. As you just saw, the advantage for the reader is to understand a big topic like 5G in a much easier way, even though it is very technical and complex. And with that, I'd like to ask the operator to start the presentation slides now. Thank you very much. Our main focus was to cover all relevant perspectives on one plate, from the technology itself to policy making and many more. During the editorial process, we used a strictly scientific work process and relied on scientific findings wherever possible. All aspects were researched, written, reviewed, and documented that way. The sources we used are linked to offer as much transparency to the reader as possible. There are interviews in text and video form, and they were conducted with scientific researchers only, with the exception of Peter Stuckmann from the European Commission, who is an expert on the policy-making process in 5G. After these introductory words about the editorial work, please let me walk you through the perspectives of the mapping. Next slide, please. A major point, clearly at the center of the map, are the health concerns. Thanks to the event today, we all just got the most recent STOA studies about this issue, and the findings are included in the map as well. On the one hand, there is a text explaining the issues concerning the health concerns, and additionally, like for all other infotexts, all studies which were used are listed and linked as well. Our aim was to show the scientific discussion and link it to the currently available knowledge from researchers, also from entities like the ICNIRP, IARC, or the WHO. To add the view of experts to this section, a double-sided interview with Fiorella Belpoggi and Anssi Auvinen is included. Additionally, the map covers the potential effects on the environment and how the scientific debate is ongoing. Next slide, please. Of course, the health concern section is closely related to the technical aspects, where the technological details are explained. The close ties are indicated by the visible links in between. This part of the mapping shows the 5G system, the underlying technological components, and the key services which 5G makes available from a technical point of view, such as massive machine type communication or ultra-reliable low-latency communication. Several infographics show technical aspects in detail too. A video interview with Professor Bart Smulders from the Netherlands helps understand the complex technical parts, such as how information can be delivered in wireless networks, or how to imagine electromagnetic waves themselves. Next slide, please. And an important part which is closely connected to all tech aspects as well as the health concerns shows the policy making, the standard setting process, the regulations, and in general the work of entities of the European Union, such as the Parliament or the Commission. And in this section also international affairs, cybersecurity, and other politic-related topics are explained. The mapping includes interviews with several experts in this field, from policymaking, international relations, and of course, cybersecurity. Next slide, please. The link from politics towards the economy are very close, because it is the job of the policymakers and regulators to set the rules for the single market in the EU. And this part shows predictions for jobs, future possibilities, which are predicted to become a reality rather soon or later, and, for example, the value chain of vendors and suppliers of 5G equipment. In a video interview with Walter Lemstra, he explains how mobile communication networks work as from the business point of view, the implementation by telecommunication companies, and the product life cycle of mobile telecommunication network generations from 1G to 5G. Next slide, please. And to make the full circle through the mapping, please let me finish with the impact on society and the economy part, which is linked with the other parts, of course. This part explains jobs, positive expectations, as well as concerns. All of them get explained in detail. Experts like Josefina Antoniou explain the relationship between technology, people, democracy, data protection, and for this mapping, especially also conspiracy theories. The history of mobile network communication is also included in this part. Thank you. You can now end the presentation. So this was a very short introduction to the mapping of 5G technology. In total, the map includes as much text as a textbook, has 9 interview partners, and many, many infographics. We welcome you to dive in and explore it by yourself. The map can be found on map.sciencemediahub.eu/5G. Thank you very much.
Thank you very much for your presentation. Now, as I told before, three discussants are invited to tell their opinion on 5G and for 5 minutes, every one of them, their position on 5G. Also to hear what they have to tell us on the basis of the presentations that we heard before. The first one, you have 5 minutes, every one of you. The first one is Joachim Schutz. He's the head of the Environmental Lifestyle Epidemiology branch at the IARC, International Agency of Research on Cancer of the World Health Organization, located in Lyon, France. Please, you have the floor, Mr. Schutz. Are you here?
Okay, can you hear me now?
Okay.
Okay, that's better. So thank you for the invitation and also for the possibility to comment here. And obviously representing the Cancer Research Agency of the World Health Organization, my comments will be on cancer. And here importantly we have heard the report on health impact of 5G, which unfortunately one of the main conclusions, and rightfully one of the main conclusions, is that for 5G specifically we have practically no data. And this actually goes even further, because looking at the studies that we conducted in humans, and for most of them the fieldwork was actually finished before the year 2005, means we also do not really have any data on 4G, and we have also very little data on 3G. So the task is really to conclude from the studies of the early mobile phone technologies and other radio frequency exposures of what we learn for 5G. But this already shows that, of course, everything is related to some scientific uncertainty. There are two quite authoritative reviews that I would like to point out, because they were from very large expert groups. And one is what you heard already, the classification by the International Agency for Research on Cancer, putting radio frequency fields in the group of possibly carcinogenic to humans. And there's also the evaluation by the European Commission Scientific Committee on Emerging and Newly Identified Health Risks. And if you read the details actually of the two reports, then you will see that they come up with quite similar conclusions. Because we should not forget that carcinogenicity is a very important but first step of the risk assessment. But when we talk about protection of humans, what we need to know is the individual risk and also the public health impact, so the risk at the population level, which means we need to understand the magnitude of risk at various exposure levels and how many people are exposed to these levels. And here, notably, we should not forget that we are not talking only about mobile technologies, but we have wireless applications all around us. Reminding for really decades, we have television, we have radio broadcast. There's a lot of military applications. We have even the Wi-Fi inside our houses. So what we can conclude is that no one in Europe is really not exposed to radio frequency electromagnetic fields. So everyone has some background exposure, which is unavoidable and also mostly involuntary. So when we do the studies of identifying risk, we look at those who have the highest exposure. And this has, especially in the past, been the people who are holding the mobile phone directly to the head, because you hold the transmission source directly to the body, and of course the emitted energy is absorbed by your tissue. And if you look at these studies of the mobile phone users, then we see quite a consistency if you look at what I call for the moment a normal mobile phone user, namely that it did not show any increased risk of brain tumors. And this is the normal user, was the people, if you look for instance at the 13-country Interphone study, was like 90–95% of the population. But where the studies are less consistent, and this is what we have heard also in the previous reports, is the risk for the heaviest users of mobile phones, these 5 to 10%, because here the studies are less consistent. We have big, large-scale cohort studies, but unfortunately they did not have the detail of information to study this group very specifically, and case-control studies, which are a little bit difficult because they have to rely on people's memory of what they report from the past, have shown some indication of an increased risk of glioma and acoustic neuroma, but not always consistently so. So this remains an open question. But what is really important to note for 5G is that all the studies that have observed an association have seen this association with the accumulated lifetime exposure to the radio frequency fields. So really more the kind of uptake of the energy in the body and less technical features of the different technologies. So for example, some 20 years back in time, there was a long discussion about whether pulsed or non-pulsed field have different biological effects. But the evidence for cancer in the human studies is really, it seems to be the exposure level that is determining the risk. So this brings me to 3 conclusions. The first one is about research, which has already been mentioned by many. And because we have seen now that mobile technologies are actually quite frequently adapted and changed, we need something like a permanent research program in place. So normally what we have is specific programs that come and go, but this is quite an interruptive process for apparently a technology that is permanently changed and updated. So we have to cope and adapt to this with a research program that also has some kind of permanent structure instead of having people building up their expertise. Then it's fading away for a while, and then we sometimes even restart the whole procedure. Secondly, what I already mentioned, the cancer question still has to be resolved. And here the key question is really the individual risk and the population risk, because this is needed for making adequate human protection. And the third one, which I really think is the question of utmost importance for the 5G, and this is understanding what the human exposure really is from this technology. So what is the uptake of energies at various body sites and organs, and this is the one that is the most needed, I think, information for a proper risk assessment at this stage. So thank you very much.
Thank you very much. The second discussant is Kurt Streif. He has reserved for almost 2 decades at IARC, WHO in Lyon, France. He was head of the section of evidence synthesis and classification and directed the programs of IARC monographs, the IARC handbooks of cancer prevention, prevention and the WHO classification of tumors. One of the many monographs developed under his leadership is the volume 102, which classified radiofrequency EMF as probably carcinogenic to humans. He is now an associate researcher at IS Global, Barcelona, Spain, and a visiting professor and co-director of the Global Observatory on Pollution and Health at Boston College. Please, Mr. Saev, you have 5 minutes.
Thank you very much, and thank you for inviting me to this important discussion. I think most of the issues have already been mentioned. Let me summarize it again. And I'm not sure if it was on purpose, but today is exactly on the day, 10 years ago, that IARC classified RF EMF as possibly carcinogenic to humans on May 31st, 2011. And this classification is still valid. And it's also not incompatible with WHO's statement that no adverse health effects have been established as being caused by mobile phone use. We have already heard what the IARC evaluation is based on, the limited evidence for carcinogenicity in humans based on glioma and acoustic neuroma, and limited evidence in experimental animals for the carcinogenicity of RF EMF. Overall, that was the 2B evaluation, possibly carcinogenic to humans. Some additional background that is relevant here. The mechanistic evidence was not taken into account for this evaluation, as it could be if there's strong evidence. But the conclusions that were included in the monographs meeting were results based on all the in vivo and in vitro studies that did not consider confounding, that considered potential confounding by heat. So all the evidence that is here summarized was that there was weak evidence that RF radiation, for example, is genotoxic. So this weak evidence means weak evidence in support. It does not mean strong evidence against any biological mechanism. Secondly, the radiofrequency EMF, the working group comprehensively evaluated all the pertinent studies, that is cancer in humans, cancer in animals, mechanistic data. And this also included at the time already occupational exposures like to radar or microwaves that are about the same frequencies as can be the 5G. But the strongest evidence was from the personal use of mobile phones. There was a kind of an intermediate update where Joachim Schütz and I was involved in a commentary in epidemiology that was led by John Sammet, who was the overall chair of the IARC working group and also included Rodolfo Saracchi, a very prominent senior epidemiologist who has worked for decades at IARC. Essentially, this also concluded that there is massive exposure. The review update didn't kind of remove the uncertainty inherent to the possibly carcinogenic, and then a research agenda was proposed, similar to other research agendas on other exposures like engineered nanomaterials. It also concluded that we need to keep the people well informed, and altogether that the IARC2B classification implies an assurance of safety that cannot be offered. What comes next is a big survey among experts of WHO, and this survey in terms of prioritization of health outcomes when assessing the effects of exposure to RF EMF concluded that several outcomes are of highest priority, and that included, amongst others, cancer and adverse health birth outcomes. In addition, as is the case with the IARC monographs, about every 5 years, an international advisory group is convened to make recommendations on future priorities for IARC monographs. The last one was in April in 2019, and this advisory group recommended that RF EMF, non-ionizing radiation, should be re-evaluated with high priority, and that was based on new cancer bioassays, but also new mechanistic data. The more detailed report that you can read also concluded that the epidemiological evidence remains mixed, but then goes on and summarizes the 2 new cancer bioassays from the United States National Toxicology Program and the other study from the Ramazzini Institute in Bologna. And both of these found increased risks of cancer, particularly schwannoma in the heart in the male rats. Now we need to know that the IARC monograph evaluation are hazard identifications, but the hazard identification is the basis for all risk assessment, taking into account in addition dose response assessment and exposure assessment. What does this mean for the evidence as it had been presented today? In terms of hazard identification and what Dr. Fiorella called the FR1, the frequencies that are already in use for up to 4G mobile communication, this is where the strongest evidence was for the IARC evaluation, and this hazard identification still stands. For the IARC evaluation on the FR2, the higher frequency, the current evidence from the 2 to 4G studies is probably still the best available evidence, given that there is no other kind of very informative studies. This is on hazard identification. When it now comes to risk assessment, we have to consider the new technological features of 5G, particularly the MIMO and the beamforming, etc. And this also results in uncertainties with regards to the exposure, but also the exposure assessment of epidemiological studies. And these differences need to be taken into account for risk assessment. For the higher frequencies, we also need to consider particular physical characteristics that impact on interactions with biological matter. That is the depth of penetration into tissue, for example, or the deposed energy, and also other metrics that may affect the outcome from the exposure. One important discussion is the importance on the heat or the temperature increase. Now, if you see this in context of the IARC monographs, there is the possibility to upgrade evidence from cancer in experimental animals, if there's sufficient evidence in the experimental data, to a higher evaluation of concern with strong mechanistic evidence. You can also downgrade it if there's very strong mechanistic evidence that the mechanism does not apply to the humans. And in that regard, having overseen almost 50 different monograph meetings, the only one with regards to heat that comes to my mind is drinking of very hot beverages, where there was limited evidence from studies in experimental animals, where temperature above 65 degrees Celsius resulted altogether into limited evidence for an increased cancer risk in the animals, and the mechanistic evidence was very scant. So I don't see, from the large overview of all the published studies on cancer in experimental animals, any reason why studies would need to be downgraded if there is, even if there is, it's not even clear if there is an increase in temperature. I will not comment on the policy issues. I think this is for you, the STOA members and the wider civil society. I have focused my comments on the science of the carcinogenicity. Thank you.
Thank you, Professor Streif. The third discussant is Professor Martin Vacha, who is Associate Professor of Animal Physiology, Immunology, and Experimental Biology in the Faculty of Science, Masaryk University in Brno, Czech Republic. Please, Professor Vacha, you have the floor.
Thank you very much for inviting me to this talk. Well, I have nothing much to say on the top of everything that was already said here. Well, my expertise backgrounds concerns more the behavioral research on animal models and not perfectly matching the 5G frequencies. But anyway, I think that some things that I can add into the discussion is what I'm facing almost constantly during my research on magnetoreception of animals that we should be concerned about non-thermal effects of radio frequencies, and that we are perfectly sure that some of sensory capacities of animals, and possibly also human, are impacted by subthermal levels of some radio frequencies in the range from single up to about 10 megahertz. So what I'm mentioning now is very, very low frequencies compared to 5G frequencies, but I'm pointing to the fact that physics and biophysics and biochemistry still do not know the exact physical models for effects. We are perfectly sure that they exist. So this is just a note that not only thermal effects should be taken into account, and that we simply do not know everything about processes about which run in the tissues and in animal bodies. So back to the reviews we talk about today. I think that both studies are excellent, that they are complete and exhaustive, that they analyzed all accessible scientific communication, and that they are relevant to the topic. They are comprehensive, realistic, factual, and I think that all outputs, like policy options, both authors conclude their reviews are well worth of policymakers' attention. I would repeat that I completely agree with conclusions that energy emissions should be reduced as much as possible, that exposure limits possibly should be revised in relation to what I've mentioned before, and that multidisciplinary research should be promoted, and also the information campaigns on 5G should be promoted. We saw an excellent map on 5G today from Julia and Bernhard. I think this is a definitely very good way to go. I would ask them later on to send us the link into the chat, because I didn't mention it. And as the last policy options was the systematic measurements and monitoring of the RF fields, especially near base stations, and preventing exposure in close proximity of these base stations. So this is basically what we heard today. I completely agree with outputs of both reviews, and I thank you for your attention.
Thank you very much. Thanks to every one of these discussants and all the presenters. I want to make a very short summary before giving the floor to Mr. Ivo Hristov. The problem with 5G arises with the fact that communication technologies are evolving faster than the science studying the harmful effects. This requires certain measures to be taken moreover the population is concerned. Here the precautionary principle is possible to be applied, nevertheless that ICNIR guidelines may be sufficient to limit the impact. Here is the suggestion to have more studies in the field of long-term, non-thermal effects, etc. We the researchers need also additional studies in the field of millimeter waves, especially for the frequency expected to be used of the 5G technology. We need also new methods of measurements and exposure assessment for monitoring the exposures, new approach for studying the harmful effects on human body in combination with the exposure of the 2G to 4G technologies. We need additional funds for performing such studies, especially in countries with pure budget. Most of these funds should come from independent sources, but only in my opinion, governments and operators, industry should be involved in the process of funding as well. There is a rule: whoever creates the problem must pay to take care to reduce the effect. Collaboration between countries is very important in the process of performing such projects. High quality of research protocols is the only way for scientific result to be accepted by the population. Scientists should strongly oppose research that is not conducted in accordance to the requirements of the scientific protocol, nevertheless if they are published or not. Scientists should be involved in risk communication campaigns to explain the results and to reduce the fake news. Very often, such news are conspiracy, are coming from people without basic knowledge and training in the field of EMF exposure and health consequences. Finally, I believe that operators owe to the population an explanation for why there is such a hurry to introduce 5G and how this technology will make the life easier to prevent the risk-benefit dependence. Thank you. I give the floor to Mr. Ivo Christov, thank you for your attendance.
I can speak in Bulgarian. Okay. Благодаря на
I should like to thank all the participants for their very interesting presentations. At the end of 2019, Mrs. Rivasi and I decided to join our efforts and to commission an overall study of the impact of 5G networks on human health and the environment. I was very surprised to find out that in the EU we had an action plan for implementing 5G without any knowledge of the potential risks. As a result of that fact and of the action plan, a number of European towns introduced moratoria, and the citizens responded acutely to the lack of information and research. There were heated debates, pro and cons, and the pandemic was used as a good excuse to accelerate the implementation of 5G. It's a fact that technologies often outpace science. So a year and a half into the implementation of 5G, these networks already function throughout the European Union. And the question now is not whether we need the technology, but how to reduce to a minimum the potential risks for people and biodiversity. And I think we should now aim to make recommendations to the regulators for specific legislative measures. And the conclusions of the two studies imply this view too. We should especially focus on the methodology for risk assessment. We should focus also on governing the risk, overcoming the information divide by organizing information campaigns, revising the rules for safe use of mobile telephony. There should be limits for exposures to the cell network, and there should be new technologies. I believe that the adequate risk assessment is key. Thank you very much.
Сега давам думата на моята колега госпожа Ривази.
And now, Mrs. Rivasi, you have the floor.
Bah écoutez, je vais faire ma conclusion en français, je suis désolée.
I'm just going to do my conclusions in French. The interpreters have to leave. I'd like to say thank you to all of the speakers. I have a variety of different political conclusions, scientific conclusions, and I'd really like to say thank you to my colleagues. It's thanks to them and to STOA that we've been able to commission these two studies. some of the MEPs are the ones who were able to mobilize and make these studies happen. Now, what I'm taking home from this is that technology is going faster than science. Ms. Belpaggi, for example, talked about the 26 gigahertz frequencies and how there are very few studies on that. What we can take from that is that we need to increase the number of studies on this type of frequency because it's not being used right now, but it might start being used within a few months or years. And we need to take advantage of that so we have more information on carcinogenic effects and reproductive effects. Secondly, is exposure. He said that we need to have a larger idea of what exposure is. Do we have some sort of map on this? Their presentation was a bit vague. Is there a way we can have a better idea of a map of how people are exposed? How can we get more specific information on human exposure, not just for 5G, but also for 2, 3, 4G, 4G plus? We don't have much of an idea on human exposure for that. Thirdly, the non-thermal effects. I maybe would like to know something about how is it possible that they only talked about thermic effects? There were these NTP studies from Ramazzini, from American University, that all talked about how there are carcinogenic effects on rats and mice. And there are these non-thermic effects that can be genotoxic. We need to look into that more. And it doesn't seem normal that these non-thermal effects are not being taken into account, nor are the animal effects. There are very few human studies. We don't have the biological marker for that. So in France, for example, there are a number of different mayors who have asked for moratoriums on 5G. And Mr. Israel was correct. Israel Michel, was correct to say that we need to have requirements on 5G.
Quand même là-dessus. Donc, il est très important de savoir quelle est l'utilité pour le consommateur. Parce qu'on voit bien que la 5G, elle est surtout au niveau des industriels. On veut faire des villes connectées, on veut faire des voitures autonomes, mais quelle est l'utilité et la valeur ajoutée pour le consommateur? Donc toutes ces questions-là, ce sont des questions politiques, mais moi je retiens plus de recherche. Tant qu'on n'a pas la recherche sur les 26 GHz, pas de déploiement. Et puis, il faut renforcer vraiment la connaissance sur ces effets athermiques, parce que si on a une épidémie de cancer, par exemple en Europe, il faut savoir quelle est la part de cancer qui est due aux ondes électromagnétiques. Et j'encourage l'OMS et notamment le CIRC de faire une réévaluation sur les radiofréquences, puisqu'elle date de 2011, on est en 2021, donc il est temps de réévaluer l'impact des radiofréquences sur notre santé. En tout cas, merci à tout le monde, merci aux participants, parce que là, oui, c'est vraiment une valeur ajoutée que vous nous avez apportée sur la 5G et ses conséquences sur la santé.
Thank you, dear colleagues, for your remarks, and I have to add also mine and see if we can follow up with specific actions. I want to thank our speakers because they are great scientists. They provide us with their scientific data. And actually, I want to thank also STOA for taking this challenge to present these two big studies on 5G, while I believe we are the only ones who can claim that we did an independent effort to have policy making based on facts. And these facts are actually not explaining why we should be in such a hurry, since we cannot cover the part where the precautionary principle lays. So if I may suggest a few steps from now on, I would have some questions, but I believe I can also answer myself that the number of devices that will be connected is really important and dense on 5G. And in the end, it's not just the exposure to near antennas if you use the 5G, but even if you don't, you are exposed. So as Mr. Tierlens mentioned from Ghent University, we need to have the information disclosed publicly. So I would call the STOA Secretariat to follow up by calling for the disclosure at least to the MEPs of this information, and then of course publicly too. I would ask to send a letter to collaborate and meet with SAM, the Scientific Advisory Mechanism of the Commission. I think it would be very important to join forces in this case. Then I think we should call for at least a year to investigate 5G and the level of investment from public actors that would take place, since it seems it's going to be around 500 billion, 2/3 of the COVID relief package. And it requires a denser coverage, of course, than the 4G. So to see also if the auctioning of the spectrum should take place in the private, because I believe it should be in public or at least private-public partnerships, so that the profit also will not just go to private hands if this is such a huge investment to do. And since we might have irreversible damage to human health and environment, as the European Parliament's several reports advise, we would like to call more to inform citizens with specific studies, and follow the resolution 1815 of the Council of Europe to demand that a new assessment will be carried out by an independent task force. So I think we also should draft a letter that we can call for colleagues to co-sign, and call for the European Union to proceed with this assessment. Finally, I agree with Mr. Israel that the rush to roll out 5G has steamrolled over concerns about reliability, security, and safety. And as MEPs, we have to make sure that safety comes first. So there are ways for this amazing technology to be deployed in a safe way and to be monitored and measured properly, so that citizens will be informed, and we will make sure that there will be no irreversible harm when this is deployed. And I think we have time to do so. So if my colleagues agree, we could have STOA to follow up with these steps, and maybe to consider to have subtitles in all the European languages of this event today, so that we can have more informed citizens, because I believe the data that you provided were excellent and very useful for the public opinion. The map is incredible. I'm very happy for the quality and the result of this work, and I believe we should increase the visibility of today's meeting in order to make sure that citizens will have access to this new tool, the map, and also to this discussion. So I want to thank you all for being with us. This is going to be an event. It's recorded. It's going to be publicly visible to anybody who wants to listen again to this discussion. And I've seen you have, many of you have added also your contact details. So I'm very happy to say that we will keep in touch, and we will follow up to your recommendations. Thank you so much. Thank you to the Secretariat and your colleagues and speakers. Thank you. And I want to thank the interpretation for expanding a few minutes, and we managed to hear my colleagues' closing remarks. Bye. Have